So the agenda for the day is going to be understanding what is natural language processing. Having understood that, we are going to understand how machines and humans interact using natural language processing, followed by the history of natural language processing, which is something which I really find very boring. But just to give you a familiarity with it, I'm just going to cover it in half a minute or so. Then why do we require NLP? The need for NLP, some applications of NLP, challenges and scope of NLP, and ultimately we are going to have a hands-on project. Now, to be very honest over here, just a second, what's in the chat? Okay, okay. To be very honest over here, how is the webinar going to be distributed today? This is something which we are talking of the project. This is something which will be accounting to almost 1 hour 15 minutes to 1 hour 30 minutes. So this hands-on project is going to be something where we are going to focus a lot today, and I don't want to really bore you with a lot of theory, so I'm going to wind up the presentation in 30 to 45 minutes from now. Okay, but understanding a prerequisite of this is really very important, and therefore we have to go through this PPT once. Now, before even moving on to the presentation, let me tell you that this is just a small webinar where we are going to have a quick introduction of what is NLP. But if you are really interested in NLP, let me tell you that first and foremost thing to understand that is you require a good background of machine learning. So you should be familiar with what is supervised, unsupervised machine learning pipeline. That is where you will understand why are we focusing on natural language processing. You'll have a good motivation behind learning and mastering this NLP skills. Okay, now next important thing that you should have idea is the basics of deep learning. Yes, not for today's webinar, but if you are actually starting with NLP, you should have some basics of deep learning, because we have this machine learning over here, we have this deep learning over here, and at the cross section of this you have NLP. And in a subset of this part, we have something called as DNLP, which we call as the deep natural language processing. So if you really want to excel in this area, you should also have an idea of deep learning. Okay, now having understood this thing, now when you actually enter into when you actually enter into natural language processing, the natural language processing is going to consist of the following things. The first thing that we have over here is how to extract our data. Now this data extraction can be from either the PDF file, it can be from the JSON file, HTML file, text file. In fact, it can also be from the APIs of Twitter, Instagram, etc., etc. Okay, now what we basically do over here is we extract the data by using the parsing techniques or scraping the data from the web itself. Now, having understood how do you extract the data, the next thing is we learn how to explore this data. So the next thing that we have over here is how to explore the data and how to pre-process the data. Now in pre-processing and exploring of the data, you come across various terminologies like lowercasing of the data, punctuation removal, stop words removal. Then you also understand what is standardization of text, how do you correct the spelling mistakes in the text, how do you perform the tokenization of this. Then two important concepts over here are, which I like to list over here specifically. The one is called as the stemming, and the second one is called as the lemmatization. Now I'll be showing you the implementation of these two because these two are very important. But what I'll be showing you is just a quick what I'll be showing you is a quick overview of what is stemming and lemmatization, although there is much into this. Then the next thing that you have is a proper EDA on the data. As you do in ML, you have to also have an EDA over here and properly have an end-to-end pipeline of pre-processing this data. Now, having done this, the third stage of natural language processing is how to convert all the above things, or how to convert all the about text that you have to features. Okay, now over here you search, you come across various techniques like one hot encoding or count vectorizer or n-grams. Now n-grams is again something which I'll be showing you in short over here. Then you have something called as a hash vectorizer. Then we have TF-IDF. A lot of things come over here. In fact, there is also something called as a concept of word net embedding or word embedding over here that comes. Now, once we understand all those things, then we can go to the next one. Let me call this thing, I'll write it over here, part D, where we actually go for the advanced natural language processing. Like we understand how do you extract the noun phrases, how to find the similarity in between the text, or how do you have a proper parts of speech tagging or named entity recognition, or something like if you want to extract topic from a text, maybe you're given a paragraph over here and you just want a summary of this in 2 lines. So extracting topic from the text, or given a paragraph over here, can you tell me what is the sentiment of the paragraph? Is it going in the positive direction, or it is going in the negative direction, or it is simply a neutral paragraph which is written over here, right? Then there is something called as word sense disambiguation. This is something which I'll be discussing shortly in this. Then we also have speech recognition, text to speech generation, and many more topics. Okay, and ultimately after this, the last thing that we have over here is understanding the deep natural language processing, where we understand how do you implement the recurrent neural network, specifically the long short term memory for predictions on the text sequences. So this is what is the entire NLP actually focuses on. So you can understand that we are just going to have a quick touch on few of the concepts over here. Precisely as I told you, the main focus for today's webinar is going to be on the TextBlob library. Okay, now what is TextBlob, how is it to be used, etc., etc., I'll be discussing over here in the next coming slides. Okay, so let me start with natural language processing. So what is basically natural language processing? First and foremost thing, it is a branch of artificial intelligence, and it helps the machines to deal with the human languages. So when you are actually talking to machine, you will be talking in a normal English language or any regional language which you want. And when you want the machine to talk back to you, we say that we require something called as a processing over here for the languages, and that is called as the natural language. Why natural language? Because the language that we speak is called as natural language. Okay, it can be any language, it can be English, it can be Hindi, Marathi, or French, etc., etc. So this is how NLP comes over here. It is something which sits exactly in the middle of AI and computer science, and of course the human language. Now, the advantage of NLP is it helps the machine to understand, interpret, and manipulate human languages. A very popular example is the Amazon's Alexa product, right? You talk to Alexa product and it does the work for us. So always remember, whenever I talk of NLP henceforth, just remember the Amazon Alexa product, so that you will be having a good idea of how a machine is communicating with a individual. Now, most of the natural language processing techniques depend on machine learning to derive the meaning from the common human languages. Okay. Now, let's try to understand how does, I'm sorry, I don't know what happened, just a minute. Uh, just a second, guys. Okay, so that was Zoom annotation problem. Okay. Now, having understood this, let us now initially focus on, okay, what's in the chat. Okay, let's focus on how machines and human interact using the natural language processing. So the first thing that you have over here is, initially human beings talk to machine. Okay, now once you are done with that, the machine is going to capture the audio of the human being. The next thing after that is whatever audio is being captured, it will be converted to the text format. Once we are converting it to text, as I told you, we are going to process the text, whatever the machine has translated. Having understood that text or process that particular text, now I'll be having my data, whatever we have processed. After processing that, we are going to again convert it back to audio. Thereafter, the machine over here is going to respond to the human through this audio file, and in this way this cycle is going to continue. So that's how machines and human interact using natural language processing. Now, coming on to the history of natural language processing. Okay, so this started somewhere in 1950, when this Mr. called as Mr. Alan Turing. So NLP started when Alan Turing revealed an article known as the Machine and Intelligence, and this article basically tries to automate the translation between the Russian and the English language. So it was right in 1950 that machine learning came into picture. Okay, uh, okay, Likhit Kumar, please explain the previous slide again if you have. Okay, I'll just explain it in short. Just a second, Nikhil. Okay. So over here, what did I say, Nikhil? Is initially humans talk to machine. Machine is then going to capture whatever the human has taught through a microphone. So it captures the audio. After capturing the audio gets converted to text. This text is now pre-processed. That is, the machine over here decides what is written in that text and what should be replied to the human in return. And after that, whatever reply is ready, that data is converted back to audio, because human beings are going to listen through their ears. Then the machine is going to respond back to the human, and in this way the cycle goes on. So that's exactly what I explained over here. So now let me go on to the history of NLP. So as I told you, NLP started when Mr. Alan Turing revealed an article known as machine translation. And over here, it basically grabs the intelligence of the machine to automate the translation between the Russian and the English language. Now, after 10 years exactly, the work of the linguistic scientist Chomsky and his other fellow mates on formal language theory and generative syntax began. Then in 1990, we had some probabilistic and data-driven models. That is the Bayesian probability model, which came over here, which had become quite popular normal. Then in 2000, after this is Mr. Chomsky. Then in 2000, a large quantity of spoken and textual data actually became accessible, because we came across a lot of data since the computers were more popular at that time. And in 2010, finally, just few decade back, the representation of learning and deep neural network in the natural language processing started. Now, to understand all this thing, it is very important over here that we understand human language, right? So when we expect that machines should understand what humans speak, it is very important that machines should initially know what is a human language. So to understand NLP, let us first try to understand what is human language. So whenever you talk of human language, we know that initially when we were in the early school days, we started with alphabets. Then our teacher taught us what is a word, which is nothing but a combination of alphabets. Next, we learned what do we call as sentence, which is combination of words. And ultimately, after that, we were learning something called as grammar, which is something which we really require today also, to make something called as a meaningful sentence, because just forming a sentence is not going to be sufficient. We should be able to form a meaningful sentence, and therefore to understand over here, NLP also has a challenge as to how to make this sentence meaningful to the human being, right? So let us now understand why do we actually require natural language processing. So whenever you talk of NLP, NLP is the hallmark of human intelligence. It is a large repository of human language, and it is growing quickly. The advantage of NLP is it represents the computer program that understands text or speech. Okay. So what do you think? Why do you think there is a need for natural language processing? When we go to the need for NLP, we have to understand that today we are having a lot of applications like Facebook, which heavily deals with text data. I do agree we also have images on textbook, but we also have a lot of text data. Similarly, if you talk of WhatsApp, this is something which contributes to around 70% of text data and 30% of the images, because images are simply something which are regular forward. So let's not give significance to those images. Then Twitter is again something which focuses on text data. Instagram focusing on images as well as text. And what is this? Can you tell me what is the last symbol which is flashing over here? Anyone among the participants? So Vanita has given an answer. Rahul, well, yes, that is something which is ambiguous, but you can consider it, as Vanita said, as hangout or a normal message, SMS, Skype, anything. But what I want to convey over here is that today we are living in the era of lot of natural language data. So we have a lot of text data to be processed, and this text data can literally be organized together. It can be simple text data, it could be structured data, it could be unstructured data, or it could also be semi-structured data, right? Now when I talk of unstructured data, it could be like I have taken a Google form and I have asked the users to fill in their phone numbers. So some of them have written their phone numbers as 97891236676. This is a valid phone number. One more person has written the phone number like this: 9789-123-676. There is one more person who has written that 97-89-12-36-76. So all of this essentially represent the same thing, but if they are written in different formats, we say the data is semi-structured, though it is in a structure, but it is in a semi-structured format. We want all of this data to be in a standard format. That's where the role of text pre-processing is going to come. What does pre-processing do over here? All these spaces, all these hyphens, all these things are removed, and this number would be simply taken as 9789123676. As simple as that. Okay, so this is one just very simple example of text pre-processing, although there is a lot into this. Okay, so the problem over here is how to understand or how to analyze this unstructured data, right? And the solution to this is very simple. It simply says to understand or to use all this data, we have to use something called as text mining over here. Okay, now what is important is to understand what is text mining. In simple words, whenever you talk, let's say if I'm talking of the terminology text mining over here, in simple word, this is also called as text analysis. Okay, so let's not give significance to the word mining, it is simply analysis. And what does this mean? It is nothing but the process of deriving insights from the natural language text, and this is where NLP is going to help. Okay, so the process of deriving insights from natural language, process of deriving insights from natural language. Okay, and over here we can further classify it into majorly three categories. The first one is we are going to structure the input text, right? As I told you, the phone number example, we are going to structure it properly so that it looks like a normal number. Next is we are going to derive a pattern over here. Okay, so we are going to understand what is that thing basically symbolizing. So let's say I have a column over here where there are a lot of numbers over here. Initially we removed all those spaces, hyphens, and we got the number like this. Okay, now having done that, we don't know what is the name of this column. I told you that this is phone number, but if you don't know that, we have to interpret what this could possibly be. So that is where we derive it, and ultimately we have to evaluate the output of this. Okay, so this is where text mining is really going to be helpful. Now let us understand the different aspects of natural language processing. Okay, so NLP is the ability of the computer to analyze, understand, and generate human languages. And as I told you, a language is nothing but a system or a set of rules or symbols, and this symbols are combined and used for conveying information or broadcasting any information. Now this is something which is really very simple or written in very layman terms, nothing as such great to explain. In NLP, the rules of grammars are used for handling the symbols, and it is one of the component of AI. Now coming on to the most important thing for today's presentation, what are the applications of natural language processing? Okay, because that is where we are going to end the presentation and move on to the coding stuff. So let me show you a few applications. The first one, as I told you, is the speech recognition application. Now, whenever you talk of speech recognition, I already gave you a few examples. Once again, to state, the first example could be my Google Assistant, right? Every one of us has this Google Assistant on the phone. Then one more which I gave you is Amazon Alexa. Now, having understood this too, can you give me a few more examples of where speech recognition is used? Few more examples in the chat, please, where you think speech recognition is something which you came across. I'm only talking about speech recognition, okay? Not specifically. Yes. I see very good examples from Ashta, Faisal, Ritu, Muhammad. Yes. So this were exactly the answers which I was expecting. We know after Alexa, we have the Apple Siri. Then we have Microsoft Cortana. So all of these are nothing but assistants. Huh? You all remember, right? If you have an Amazon Alexa over here, you can simply say, Alexa, turn on welcome home. Or Alexa, turn on my chill time. Or we can say, Alexa, turn on my soothing songs, or turn on the TV. So all these things can be done with the help of a simple machine, and this machine works on the concept of speech recognition. Yes. Now let's not come to the chatbot. That's not something which I want to discuss in this point. The next one is machine translation. Now, who doesn't know machine translation? A simple example for machine translation could be the Google Translate. If I simply go to Google and I simply say translate English to, let's say, Hindi, and if I write, hi, my name is Darshan. Hi, मेरा नाम देखो. Okay, is ID is Mera Naam Darshan. Now you have to understand over here, what is this? This is nothing but the example, a real life example of machine translation. Now, what do you understand over here? Now, this looks very simple, right? This simply got converted into the language of my choice. But let me tell you, friends, this is not as simple as what you are thinking. In fact, this is where my deep natural language processing model is running at the Google has, and Google doesn't do simple things. There is a deep learning model behind it, which is helping me in have this answer very near to what I expected. Right? So in fact, you can see the precision over here is as good as 100%. It has clearly or perfectly translated whatever was my expectation. Now, let me move on to the next one. The next one is chatbot. Okay. Now, we all know few examples of chatbot, right? So the first one, if you have traveled by Uber somewhere in the, what do you call, foreign countries, Uber has a chatbot. In fact, our Facebook Messenger also has a chatbot facility. Our Zendesk is one of the application, if you have ever used, has chatbot facility. So these all are the companies who have heavily implemented chatbots using NLP. In fact, you can also go to the Amazon website. Let's say you have bought a particular product and you have some queries related to that product. The moment you try to call Amazon, initially a chatbot opens, and if you are satisfied with the service of the chatbot, your issue gets closed. Else you can choose to talk to the representative. So almost Amazon has reduced 70 to 80% of their work only by implementing the chatbot. So all of the representatives who were initially handling all of the stupid requests from the customer were now relaxed, right? So they can utilize their time for something better. So that is the advantage of chatbots. Okay, so Sheikh says, what is chatbot? That's okay. Let me go to my Amazon, and let's say I go over here, maybe my orders. So let us say this is the simple order which I have. Sorry, that should not be the place. Okay, chatbot facility is not available on this. Chatbot facility is available on the mobile application app. It's not available on the desktop version. But yes, chatbot is basically a machine through which you can talk. A simple explanation. So it is basically a machine through which you can talk. Now the next one is my information retrieval. Right now, information retrieval is something which we are going to use today when I show you the text block. So what does it do? It basically finds the information according to the given query. Okay, now there are popular information retrieval techniques in natural language processing. Some of them, as I told you, is going to be my stemming. Then there is one thing which is called as the POS tagging. So given a sentence, you properly tag the parts of speech over here. You also have a technique which is called as word sense disambiguation, which I'll be discussing shortly in the upcoming slides. So in fact, Google also finds the relevant and the similar results using the information retrieval, right? So a simple example could be, if I simply go to Google and I simply go over here and I search anything over here. Let's say I search over here, what are chatbots? Now, whenever I'm searching and pressing a enter over here, how is this information getting retrieved? How are these queries being processed? How many results are shown over here? There is some algorithm which is running behind it. There is some deep learning library running behind it, with the help of which the popular answers are shown over here in a sequence. Right now, after that, if I want to see more number of pages, I can also go to 2, 3, 4. So what is this? This is nothing but information retrieval, and it is heavily relying on the text pre-processing capabilities. The next one is the information extraction. Now, when I talk of information extraction, we also it is basically the automatic extraction of the structured information from the unstructured or semi-structured machine readable documents. Okay, a very simple example over here is, let's say you have received a email from any person, and if that email is, let's say, a invite for a conference. Okay, so you'll be having something over here, uh, dear Mr. So and so, we are glad to invite you for the conference at this particular time. So at this particular time on 22nd of November 2020 via Zoom on dot. Now whenever Google reads any such mail, now obviously when I say Google does not read it. It is the NLP model which reads that particular mail, and it automatically finds the keywords over here and finds that this is nothing but something symbolizing a venue over here. So it automatically tells you whether you want to set a reminder in the Google Calendar considering this information, and you can actually set a reminder in the Google Calendar automatically. Okay, you can see this, or you might have ever experienced it if you are very familiarly using Google. So all these things of automatically understanding that this is a venue, this is an invite, and I can set a reminder for the person. Are basically, why are all these things given? These are given for a good user experience, right? So Google always focuses on that. And what is this particular concept called? This is simply called as information extraction. So the simple example, as I told you, Gmail structures event from the emails. Let's go on to the next one. Spell check. Now understand what is spell check. Now spell check is something which our what do you call Salesforce, if you might have heard of Salesforce. Salesforce has implemented the spell check in the contact forms using NLP. In fact, why Salesforce? I'll give you a very simple example for Google only. Google is so heavily investing. So let us say I am simply creating a mail over here and I say, it's pleasure to be with you. I am happy. Okay. Now, surprisingly, nothing is happening over here. Usually I get it, but surprising. Just hello. Okay, see over here. So I say I have simply written hello Eduonix. I am HAPY. So I'm happy to deliver this webinar. So I simply write I am happy and I put space to deliver this. So you can see automatically it is rectifying. So if I click over here, it is recommending me that this is the word. This is a suggestion over here. So this is nothing but spell check. Okay. So I don't want to go into the details of that. In fact, spell check is something which is also available in our Microsoft Word, right? Now there is a question in the chat who is saying, sir, how Word and Gmail is automatically correcting the grammatical errors? That is because they have a pre-fed words of dictionary, a collection of words stored in the dictionary format in the Word. And Gmail is something which has a proper NLP engine running behind it, Sheikh, which actually helps it in suggesting the word. So this is a very big thing that you have to understand. So this is something which is not very small and something which can be understood in a single thing. To understand this, you have to understand a good idea, or you should have a good idea of what is natural language processing. So for now, just understand that it is a deep learning framework which is running behind it to correct this spellings or immediately give the proper suggestion for the spellings. Well, the next one is question answering. Now, when I talk of question answering over here, the system automatically answers the question. The popular example would be the IBM Watson, if you have ever experienced this, or a chatbot can also be considered as the simple example for this. The next one is sentiment analysis. Now, what is basically sentiment analysis? To understand the sentiment. So let us say I say, hi, I'm very happy. So you should understand that this is a positive sentiment. If I say, I am very sad that Mr. X is no more. So there is a negative sentiment over here. And I have a sentence like, I'm going to play. So there is nothing happy or sad in this. It is a neutral sentence over here. So to extract the subjective information from a piece of text is called as sentiment analysis. So over here, we basically see whether the author is being subjective or objective, or even he is positive or negative. In fact, the project that we are going to do today is mainly going to focus on this thing only, on sentiment analysis. Now let us understand the challenges and scope over here. The first one is the nature of human language. So the rules that dictate the passing of the information using natural language are not going to be easy for the computers to understand. Point number one. Second, Unfortunately, only 21% of the data in real life is structured data, and a lot of information in the world is unstructured. Lastly, the process of reading and understanding English is very complex. Okay, I'll give you some examples to understand why is this thing, or why are these three the main challenges in natural language processing. Now, these are the points that we should understand. The first one is semantic meaning. Understanding a word with respect to the context is something which is very important whenever you talk of semantic meaning. Okay. Likhit is asking, what, sir, what is structured data? I already explained you sometime before, Likhit. Okay, so let me please go ahead. So when you talk of semantic meaning, of course, I'll be giving you examples of each of this. Right now, when you talk of semantic meaning, it is simply understanding a word with respect to the context. The next one that we have over here is entity extraction, which is simply extracting the unknown entities in the language. The third is anaphora resolution, which is the absence of important entity in the text conversation. When you talk of multiple intents, users speaking many things in a single sentence is an example of multiple intent. And word sense disambiguation is actual context of the text is kind of perplexing. Let me explain all of this to you in detail. So when you talk of the very first one, semantic meaning. Okay, so what is semantic meaning? Let me give you example to make or simplify this. So we have this two sentence. There are many good plans available on Vodafone Red. So I'm talking of a SIM card plan, right? And the second is, I want to purchase a red shirt from Park Avenue. Now, what do you see over here? The word red over here has different meaning in different context. The first one is respect to the mobile plan, and the second one with respect to a proper shirt. And that is where we have different meanings over here. So this is an example of semantic meaning. Okay, so this is the problem with natural language processing which machines face. Now, as a human, we do understand all of these things. All of these two examples are purely different, but machines do face problem over here. So we have to tackle all these scenarios. The next one, as I told you, is entity extraction. So what is entity extraction? Just sometime before I told you, whenever you talk of entity extraction, it is extracting the unknown entities. An example could be, so I have a very simple solution, example over here. A 5 molar solution of calcium chloride consists of 250.86 grams of calcium chloride dissolved in enough amount of water to make 1 liter of solution. Now, what is the problem over here? Understanding and extraction of CaCl2 as entity in this context is going to be complicated task, right? So what is CaCl2? Understanding that this is a molecular formula, so my machine should also understand chemistry in this case. So all these things come in the entity extraction task. The next one is the anaphora resolution. A simple example. Rohan and Rehan are friends. He is living in Mumbai. Can you tell me over here, who is this person he who is living in Mumbai? Can anyone in the comment section tell me over here, who is this Mr. He? Yes, Rahul. Rahul has got very emotional with chemistry, calcium chloride. So Rohan and Rehan are friends. He is living in Mumbai. Right? So Vanita is saying Rohan, but I think possibly it could also be Rehan, right? That is something which is a confusion. We really cannot conclude. It depends on who is the person who is talking, in what slang is he talking. Is he talking with respect to Rohan, or is he giving more subjective importance to Rehan? So there is an equal possibility of both, and that is where even a human being will be confused. So machine is bound to confuse, and such a problem that you see over here is called as anaphora resolution. The next one, multiple intents. Now, this is something which is multiple intent. Just observe over here. My bank account is functional. please provide me resolution process, and I want to buy a mobile from Amazon. Now you just see over here in these two sentences, I have given a lot of information which is enough to confuse a machine. So I am saying that my bank account is functional. Please process the resolution process. So all of this thing, I mean to say, right from this particular, right from here to here, we are talking of bank account. And immediately after this, I am talking of processing of mobile. So you can see over here that this is one entity which is carry forwarded between 1.5 sentence, right? This is first sentence and this is the second sentence. So 1.5 sentences, the single entity is being taken, and over here the second entity is coming into picture. This is the problem of multiple intents. Yes, Mohammed, I'll be sharing the PPTs. Don't worry about that. Right now, what is important is you understand. Okay. Internet is full of examples. Okay? In fact, if you go to Google and search for these topics, you will get all these examples. Nothing is something which you will not find on Google. So what is important right now is to understand. I will definitely share the PPTs for you so that you have everything at a single place. So having understood that, the next task that we have is word sense disambiguation. Now, what is exactly word sense disambiguation? Let's understand over here. Example. Now, this is precisely classified into three categories. The first is called as lexical ambiguity. Now, when you talk of lexical ambiguity, the fisherman went to the bank. Now, the problem over here is the bank could be the normal bank where we deposit money, and it could be the river bank also. And this is the confusion. And therefore, we call there is a word sense disambiguation over here. Next one, syntactical or grammatical ambiguity. Visiting lecturers can be boring. Now, the problem over here is, does he mean to say that visiting, relatives? Visiting relatives can be boring, or visiting relatives can be boring. What is that the person is trying to say? That going to visit the relatives is boring, or relatives visiting our place is boring? This is something which is a question mark in our case. Do you all agree that this sentence is confusing for human beings also? Right? Do you all agree to this? Yes. Now the next one is the reference of a pronoun. The boy told the father about the theft. He was very upset. Now, who was upset? The boy was upset, father was upset, or unfortunately, the thief was upset. Yes, again, there is a confusion over here, and such a confusion where the reference of pronoun is causing a problem is called as a word sense disambiguation problem. Is this thing clear to all of you guys? Clear to almost everyone? Yes. So now, yes, I also, what is the difference in between these two? Between which two? The last two. So the last two, as you can see over here, the problem over here is the grammatical ambiguity. Visiting lecturers, sorry, I don't know why am I always telling lecturers. Visiting relatives are boring, or visiting relatives are boring. Okay. Is it boring to visit the relatives, or are many visiting relatives who come to my home is a boring task? So there is a problem with the grammar, and therefore we call it as a grammatical ambiguity. Whereas over here, the boy told the father. So this is the first subject, this is the second subject, and we say he was very upset. So now the question over here is, this he is for the first subject or for the second subject? So the problem over here is caused because of the pronoun. Therefore, we say the problem is reference of pronoun. In simple words, all of this are broadly classified into one thing, which is called as the word sense disambiguation. Okay. I just read it. This is similar. Rohan, Rehan sentence. What is the difference between these two? So let me go back. Yes. So anaphora resolution over here, as you said, that Rohan and Rehan are friends and he is living in Mumbai, right? So as I told you over here, whenever you talk of anaphora resolution, how did we classify anaphora resolution? First and foremost thing, we have to understand that whenever I talk of anaphora resolution, I said that it is the absence of an important entity in the text conversation. Okay, so important entity is absent. So we can see over here, the problem over here is with the subject, right? They are quite similar. I do understand there is a kind of confusion over here whenever you talk of anaphora, but try to understand the definition of anaphora and you can Google more about it. It's not at all difficult. So it is basically the absence of important entity in the text conversation. This is where you talk of anaphora resolution. And if you talk of word sense disambiguation, there is a problem with the confusion of the words. Okay, so there is proper confusion of the words over there, whereas when you talk over here, the problem is with the anaphora, or you can say the important entity over here. When I say Rohan and Rehan are friends, we are very much concerned about who is living in Mumbai, and that is something which is causing a problem over here. I hope this clears your query. Thank you. Okay, now let us start with the project for today. I'm going to close this. I move on to. Okay. So as I told you, we are mainly going to focus on the TextBlob library. So what is TextBlob? A lot of pre-processing things can be done in TextBlob, but let me tell you that TextBlob is not the best one available in the market. There are many other available like the Spacey and the Gensim for doing the text pre-processing. But let us start with TextBlob because understanding this is equally important before we proceed to this advanced libraries. So now, Likhit, have some patience. I'll be explaining you about stemming and lemmatization in the code itself. Okay, so now let's import TextBlob initially. So I say, yes, thank you, Likhit. So I simply say from TextBlob, let's import TextBlob. So we are done with this. Importing would be done. Now let us have a very simple sentence over here. Yes, Suraj, this is Jupyter, this is Jupyter Notebook, TER. This is Jupyter Notebook. So once we have successfully imported the TextBlob library, let us see the various ways of TextBlob first. Then let us look at a very small project, and then we'll be looking at the main project of sentiment analysis. So I will not be directly jumping on with the project. That is something which will definitely confuse you all. So let us look into the very first thing of basics and then go into the detailed stuff of it. So I have simply imported over here. After importing, I simply, let's have TV is equal to TextBlob of. Now I can give a sentence over here. So let that sentence be, observe over here. I have purposely written this sentence. So I say Dr. Darshan Ingle is the, okay, I'm not purposely not leaving a space over here, is the, once again I write the uh, one of the trainers associated with Eduonix learning solutions. Okay, a simple sentence which I have written over here. Now the first thing which I want to show you over here is the parts of speech tagging of TextBlob. Okay, so for that I have to simply use tv.tags. Okay, it is a simple attribute over here, and you can see over here. So DR is NNP, Darshan is NNP, English NNP. Now what is this NNP and all? Just scroll down over here and entire thing is written over here. When I talk of NNP, it is a proper noun. Okay, so all of these POS tags I have written over here, and accordingly whatever tags they are properly being classified over here. So if you observe at the start, let us see, the is the determinant over here, then Ingle is the NNP. You can see how powerful it is. Trainers is NNS. Let us understand what is NNS. It is the noun which is plural. For example, desk. So you can see how powerful this library is to automatically see this. Likit is saying it is showing no module found. Where are you finding this? I don't see anywhere in my notebook. Are you trying to do the execution simultaneously? Well, don't do all these things. You will be losing the context from the webinar. I'll be anyway sharing this notebook with you, and you can do it later, Likit. Because what is important is you understand the things right now, and then, because I'll be writing a lot of things, and later on you will be definitely disconnected with it. So just focus right now on understanding the stuff. So many tags are there. You can go through what all are the different tags available over here. So these are nothing but called as the parts of speech tags. Now there is again a feature of noun phrase extraction over here in TextBlob. So noun phrases are simply access to the noun phrase property. So I simply say over here tv dot noun phrases. You can see automatically suggesting for me. And you can see Darshan English is one of the noun phrase, and Eduonix learning solution is one of the noun phrase. See how powerful it is to automatically recognize the nouns. Now, let me give you a small introduction, because this is something which I'm anyways going to do in detail. Sentiment analysis. Okay, so whenever you talk of sentiment analysis, the important thing that we should know over here is the sentiment property over here is going to return us a named tuple in this particular form. So it is going to be looking something like this. We will be having output as sentiment. The first thing that you will be having is the polarity value, and the next thing that you will be receiving would be the next thing that you will be having is a subjectivity value. Okay, the polarity value is always the polarity value will always be between -1 to +1, and the subjectivity value will always be between 0 to +1. Okay, understand this. Where whenever I say 0, 0 means this thing is going to be very much objective in nature, and when I say 1, this is going to be very much subjective in nature. Okay, subjective means quite theoretical, objective means talking to the point. So let us see few of the examples over here. So let me have my example 1 as the variable, and I call TextBlob over here. Let me have a sentence over here. I say Eduonix webinars are superb. I recommend them to all. Okay, very simple sentence. I can simply print the sentiment of this by having a print statement over here, and I say ex1 dot sentiment, and I'm done. So you can see the moment I do this, you can see the polarity of this is 1, right? So it is quite a positive statement. Therefore, we have the polarity as 1, and it is quite theoretical in nature, right? Therefore, we say the subjectivity is also 1. In fact, we can also print the polarity separately if you want. So I simply write over here print. Let me have a slash n over here before printing it, though it's not required. Okay, let me remove it. Not required. I say ex1 dot polarity. Okay, so we can see only the polarity part is extracted if you are interested in that. Similarly, you can extract the other part also, but right now, let me show you a few more examples. So I have one more example over here, and let me change the sentence for you. I say, Eduonix webinars are amazing. What great fun. Maybe an exclamation mark. I will always recommend it to my colleagues. Okay, fair enough. And let me do it in ex2, though it's not important. And ex2. So we can see over here, unfortunately, we are not getting the polarity as 1. Okay, that's what I wanted to show you over here. It doesn't mean that the things are always going to be great, but you can see the subjectivity over here is also reduced and the polarity is 0.5. And so this is how the NLP processes this task. Now, let me take one more example over here, some kind of negative example. So I'll just take it above. Okay, I say my wife's behavior is so confusing to me. Okay, that's not the true case. This is just for example purpose. I'm taking it. Please don't tell her. So I have this, and we can see over here the polarity is minus 0.3 and the subjectivity is 0.4. Okay, so I'm just trying to show you the different ways of understanding the sentiment analysis. Now let us go on to tokenization. Now tokenization is again an important thing in text pre-processing. Now you can break the sentences into words in tokenization. Okay, so over here, let us say I have a corpus of sentences. So whenever you have a set of sentences, that is called as corpus. So TextBlob need not always have a single sentence. It can have multiple sentences. So I'm just going to write over here these multiple sentences. I say, I love the Eduonix training. So that is my one sentence. Now observe over here, after writing this one sentence, I'm not putting any comma as such. I'm simply going to the next line and I'm writing the next sentence. So I say they have, sorry, I'm not flaunting about myself. Just these are demo sentences which I have taken, and I shall recommend it to my friends. Okay. So I have the following things with me. Once I am done, I can directly use this dot words. Just see what happens. Okay, let me initially print the corpus. So you can see it prints all of this together. But if I want the words from this, we can see, okay, this is where I committed a mistake. All these words are being taken out. Okay, so all these words or the tokenization, whenever you talk of tokenization, it is basically breaking down into single words. Now unfortunately we can see that dot and they have been taken together, right? Now I can also have something called as corpus dot sentences. Observe what it does. It has said that there is a single sentence in this. Okay, So sentence objects have same properties and methods as TextBlob. So you can also find out what is the sentiment of this particular sentence. For that, I can simply say that for corp in corpus dot sentences, because we already know what are those, I say please print for me the corp dot sentiment. Fair enough. So you can see the polarity is 0.6 and subjectivity is this. So that's how it goes. If I consider instead of this, let's say only corpus, that will be an error because it is not having an attribute. Okay, fair enough. Okay. Now moving on to the next thing, which was the question which was asked, but I'll be coming to this after some time. The next concept that I'll be telling you now is called as word inflection. Okay. Now each word in this text block is going to be called as a word object with useful methods. Example is going to be word inflection. Okay. Now what is word inflection? If I want to find out the singular value of a particular word, or the plural value of that particular word, all these things that I do with word to find out the singularity or plurality of that is called as word inflection. Okay. Now for example, let me have a sentence over here. So I say let this sentence be equal to TextBlob, and I say this webinar shall definitely take my understandings of NLP to the next level. Okay, the simple sentence which I have taken over here, and after that I simply say that please print sentence dot words. Now we know what this is going to do. We have simply divided it into a lot of words. Now we have to understand over here, when we have sentence of words, this is at index 0, this is at index 1, this is at index 2. Why? Because we have got a list of this. So to be precisely, I can say this is at index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the reason I wrote it over here was I want to access this. So let's say I'm talking of the sixth word, understandings. Okay. So I simply say sentence dot words. In this list, I want to specifically talk of the word which is at the sixth index, which is nothing but understandings. And I use the word inflection property, which is nothing but the singularize function. Now just observe what this thing does. You can see over here, understandings got converted to understanding. Now similarly, I can use this for anything, but I'm not going to do all those things and unnecessarily have a waste of time. I will say pluralize. Okay, pluralize. URALIZE. And let us say, let's talk of the word level now. Now level is at index 12, so I can write 12 over here. And we see the plural form of this is 12. In fact, you can also write instead of this as -1, because list also supports negative indexing. And this is again going to talk of levels only, and we get the output as levels. Is this concept of word inflection clear to all of you? In the chat section, please. Suraj, I already explained what is subjectivity. In fact, I explained it twice before. Okay, great. Now let's go ahead to the next thing, stemming. Okay, now stemming and lemmatization are the concepts that I'll be covering over here. Very important concepts for natural language processing. Now, what is basically stemming? Okay, stemming is the process of, let me write it, this will always help you. Stemming is the process of extracting the root word. Most important thing, extracting the root word. For example, if I have word like fishes, the stem of that would be fish. Okay. If I have the word called as fish, the stem of that would be fish itself. If I have the word fishing, the stem of that would be fish. Now, what I understand from stemming over here is stemming simply truncates some part of it and gets the word. So there is nothing to truncate, it gets the word. There is something to truncate, it gets the word. So what does stemming do? It calculates the root of it, and for doing that, it simply crops the later part of the word to get it. Understand this word. It simply crops the later part of the word, because lemmatization is going to be exactly contradictory to this. Okay. So lemmatization is something which is always better compared to stemming. So Sika, we will do all that. Just have some patience. Let me start. Please consider this as an offline session. That is, I as an instructor is standing in front of you and delivering a lecture. So let me please complete with the concept, or at least reach to the 50% of the concept, and then come to a conclusion of asking any questions from your side. Okay. So please let me complete it, and then I will take with your simple query, because I am very sure by the time I complete this, your query between fisherman, fisher, everything would be clear. That is sure from my side. Don't worry about that. Okay. So it is very important that I start from zero, so that you understand the things and everyone else over here also understands. So great. Uh, for understanding what is the process of stemming, as I already gave you an overview, let me just label it so that when I surrender this notebook to you, you will have an understanding. So whenever you talk of stemming, it is extracting the root of the word. Now, where does this stemming stay? It stays in a class called as Porter Stemmer, which is available in the NLTK library. So again, you have to install NLTK for this. I already have it installed. So I say from nltk.stem, it is a sub package inside NLTK. I simply say import for me Porter Stemmer. Okay. Now we are going to use this Porter Stemmer to find the stem of the words. So I simply create an object of this Porter Stemmer. So I say I'm going to create an object of this and use this object for doing multiple number of tasks that you want. So I have a print over here. I'll be using this again and again. So I'll just copy this and I say over here, please give me the stem of the word fish. Oh, sorry. Please give me the stem of the word fish. Okay, I can take this again and again. I give one more thing. Please give me the stem of the word fishes, and please give me the word fishing. Okay. Now let us execute it. So we can see all of this have come perfect. But there can be scenarios where the things are not perfect. As Sika said, if I write fisherman over here, oh sorry, fisherman over here, it will not extract anything from this, because obviously this is considered as a single word. Okay. But there are still a lot of problems with stemming. Okay. Now, okay, let me add one more thing as Sika said. So if I have something called as fisher over here, this is also kept as, because fisher is a single word. Okay. So you have to understand what can be cropped, what cannot be cropped, and ultimately it is a library. Okay. The library is trained in a particular manner to do the things for you. But let me have few more things for you. So I say over here, let me have it. It can be words also. So it can be sentences also. If I say I like fishing, so you can see the output is I like fish. Let's say I have a sentence like I eat fish. So you can see the output is I eat fish as it is. Oh, one last one. I say over here, there are a lot of fishes in the pond. Okay, so in this case, you see over here that fishes has been kept as it is. So it is how the module is being developed. But now I will tell you the next way of doing it is called as lemmatization. Now, before moving on to that, let me tell you, whenever you talk of stem, I told you that stem is nothing but extracting the root of the word. So if stemming is giving us very good results, why do we actually go for lemmatization? Okay, now whenever you talk of lemmatization doesn't simply crop the words as it was done in stemming. Whenever you talk of lemma, if you google what is the meaning of lemma, the meaning of lemma is meaning itself. So whenever you talk of lemma, it understands what is the meaning of the words and accordingly does the substitution. Okay, so the lemmatization is the process of extracting the root word considering the vocabulary. So again, over here you extract the root word, but you also consider the vocabulary. Okay, now the parts of the speech of the word is determined in the lemmatization, and it will return a dictionary in the form of a word which must be valid while stemming, just that it extracts the root word. In fact, I would say in simple words that lemmatization can give better results compared to stemming. Okay, a simple example, let me give you a simple example. If I consider uh, some words, let us say I have given a word like leaves. Okay, and if I am applying the stemming on that, the stemmed form of leaves is going to be leaf. Sounds good, right? But I will also show you one more example over here, that instead of this leaves, if I consider a word as leaves, the stemmed form of this is going to be leav, because stemming is not going to cut have leaf. You can see, in fact I'll also show you the execution after a while. So this is something. But if you observe the same thing in case of lemmatized form, the lemmatized form of leaves is going to be a leaf as expected, but the lemmatized form of leaves will be intelligent enough to replace it by leaf. So singular form is automatically substituted considering the vocabulary part of it. Let me show you the demonstration of this. So if I simply go over here and I say print the leaves, and one more thing, I say leaves. Observe over here, as expected, as I told you, we are getting this answer. So now let us try to use the lemmatization and see whether whatever I have written using the marker pen is right or wrong. So for that I have to import from TextBlob the word class. Then I simply say, using the function of that particular class, let me give a word. Let us initially give a word like running, and I say w dot lematize. Yes, that's the word. Okay, now observe what happens over here. So if I say w dot lematize, you can see the output is running itself, so it has not done anything wrong. Now let us do it with the word leaf. So I did not import it over here, we don't require it. Instead of running, if I have leaves over here, obviously as I told you, the output is going to be leaf. We all are convinced with this. But what's going to happen if I consider leaves over here? So if I have leaves and if I execute this, it is leaf. So it kind of proves that, you know, lemmatization is a better stuff compared to the stemming. In fact, one more thing, in fact, even you see over here how beautifully it converts the word went. So if I say lemmatize of this, and the output is went itself, but if I give over here, I can pass in this lemmatize function as to what form I want this went to be converted. So I say I want this to be converted to the verb form, therefore I write v over here, and you can see the verb form of this go is getting reflected over here. Thank you, Likit. So now we understand that lemmatization is a better choice to go for compared to stemming. In fact, nowadays no one goes for stemming when lemmatization has come into picture. So it is kind of very popular compared to stemming. Now let's go ahead to the next thing, which is called as word list. Okay, now word list is just a Python list with some additional methods. Okay, let me write over here. Okay, for example, I have over here animals list. Okay, so let me have over here animals like elephant and shark. Fair enough. Then I simply say, please print for me animals dot words. Now we also know what is this going to do. Nothing great about this. I say also print for me animals dot words dot pluralize. So observe what happens over here. I think there is a spelling mistake. Yes. So you can see automatically everything is getting converted, right? So this is word list. Now the next thing that I will like to show you is the spelling correction of the text block. So spelling correction. So now spelling correction can be easily done using the correct method. You don't have to, actually beat on your head anywhere. So the simple thing over here is, let me have a text blob sentence over here and just observe. I say I have a good knowledge of spelling. Wow, I really have a good knowledge of spelling. And I simply say over here, print b dot. As I told you, simply using the correct function is going to make the things simple for us. See how beautifully it has converted. I have good knowledge of spelling. What more you expect from the library, right? So as we see over here, what is basically done over here is correction, right? Now there is also something called as spell check available over here to check if the spelling is right or wrong. Okay, so spell check. Let's see what it is. So for that, I have to, actually I had already, but just for your knowledge, you should know from where it comes. Therefore, I read from TextBlob. I say, please import for me word. Now I create the word function, and inside this, let us say I'm giving a word like fallibility. Okay, so I want a wrong spelling, or let me give the right spelling. Okay, and now I'm going to simply say w dot spell check and just observe the output of this. If you observe the output of this, the output, oh sorry, okay, now if you observe the output of this, as I told you, the output of this is going to return a list. Observe over here, the output is written as a list, and this is a list of two things. The first is going to be the word itself, and the second is the confidence in that word. That is the confidence with which it is saying that the word is spelled correctly is 100%. Okay, 0 means 0%, 1 means 100%. It is always between 0 to 1. Okay, so okay, let me give you a few more examples. So I just take a list of words. So I say, let this list of words be let the first word be love, the second word be mistake, the third word be professional. It's quite correct. The fourth word is spelling. The fifth word is laptop. Okay, I'm just spelling it the right way so that you understand what is expected. And the last word is computer. Fair enough. Now let us apply this on this entire list. So I use my for loop. So for I in L, I simply say that W is equal to word of I. Fair enough. And please print for me W dot spell check. Fair enough. Now observe over here. This is the kind of output that you expect. So you can see over here, love is 100% right. The prediction is quite right in the library which it is giving as output. So all these predictions, it is saying with 100% confidence that this is something which is expected. But when you came to the word called as spelling, it has nowhere founded it as spelling, because obviously this is more similar to this words, sparing or sealing, right? So chances of this coming are very high. In fact, it says that this word is quite near to sealing, and there is 20% confidence that this could be sparing. Similarly, for laptop, you can see the confidence levels are quite bad, because no one will be able to predict that this is a laptop, right? Because this is having quite of a Hindi slang saying that it is laptop, but we don't say it usually, right? It is totally wrong. And computer over here quite beautifully recognized. It could be a computer with 75% composer and capotes with this person. Okay, so Vanita, just once again, what do you want to see? Okay, just observe. You just have 5 seconds with you. Okay. Still, once again, I say don't write the code. Anyways, I'll be sharing the notebook with you. Now I can also get the word and the noun phrase frequencies over here. Now there are two ways of getting that. The first one is using the word counts dictionary. So let me write what am I doing over here. I'm trying to get word and noun phrase frequency. When I say frequency, it is basically the count of how many times the word comes. So let us say this TextBlob, I say TextBlob is cool. Let me write one more sentence over here. I say this cool thing is rising my interest in cool things of NLP. Okay, I'm purposely repeating the word cool many number of times. Now I simply say ss dot word underscore counts. Okay, and it simply asks which word are you interested in counting. So I have to simply give it in the form of list, and I say I want to count cool. You can see over here it has counted the word cool total how many number of times? Twice, right? So the word cool is being counted twice over here. This is one thing, and this is the second thing, right? I was expecting it to give the answer as 3, but anyways, let's see how it works. So I see over here it is not case sensitive. So ss dot word underscore counts of cool, right? Now the second way is to directly use the count method. So I can directly say ss dot word counts, and I simply say, let me give the word cool once again. Quite surprising. Oh, not underscore. I always commit this mistake. It's dot. ss dot words words dot count of cool. Quite surprising. It has to work. In fact, also here I'm quite surprised with the result. It should have been ideally 3, because it also takes into account the case sensitive alphabets. And ss dot words dot counts, this could be count, that could be the possible mistake over here. Yes, but again the problem over here is I expect 3 over here. I don't know, when I executed this thing long time back it was giving me 3. Maybe the function has started behaving in a different way due to the update in the library. Okay, now I can also have a proper case sensitive thing over here. I can say ss dot words dot count, and let's say I am interested in the word cool, and I specifically say over here case sensitive is equal to false. So okay, still I am not getting this answer as expected. Don't know what is the reason, quite surprising. Anyways, if I, let's say I add one word cool over here, and if I execute this and then I execute this, case sensitive is equal to this is true, and if I have this it is 3. That's fine. So you can see over here, if I keep the case sensitivity as off, it is going to count cool 1, 2 and 3 number of things, but this should have been actually counted, but I am also surprised why. Okay, so we got this. Okay, no, I'm not getting it. Anyways, not an issue. There might be some, definitely an update in the library which is causing it. Bala is saying it is the codes which is causing the issue. Why should be the codes causing an issue, Bala? Because this is one sentence and this is another sentence. Oh, okay. Okay, so this space should definitely, thank you very much. So I'll tell you the problem over here was this cool followed by this next string. It was ideally considering it something like this. Thank you very much, Bala, I got it. This thing was considered as a word like this. What I did now is I put a space after this, so now it is considering cool as a word and this as a different word. So now if you observe over here, I'll remove this. Now this is something which I don't want. I'm happy with this. So we can see word counts over here has counted the word cool thrice. So it is not relevant to the case sensitivity. Whereas if I use the words dot count function, okay, this has again counted it thrice. Okay, and this case sensitivity will be having, when you keep it as false, as thrice. When you keep it as true, it will be simply giving you 2 things. Okay, now okay, so this is the word, this is the sentence that we earlier had. Darshan English, one of the trainers associated with Eduonix Learning Solutions. As I told you, we can also extract the noun phrases over here. I'm purposely doing it again because I have to show you something extra in this particular part. So I have this, and now I simply say that I want specific information about this. So I said, can you count for me? So I am using the count function because that's something which we are doing. And can you count for me Darshan Ingle? And you can see over here, it clearly says that Darshan Ingle noun phrase is there in this particular sentence. How many number of times? 1 number of times. Okay, quite simple. So what we are doing right now is just very basics of NLP. Now, after that, we can start with the project. So the next important thing which I want you to understand is the n-grams module. So this is again very important. Now, words usually have sometimes connections, like when you say thank you, good morning, so I love you. So all these words usually come as a couple together. Thank you, right? Good morning, good night. All these words come together. So all these words are called as n-grams over here. When you talk of the word thank you, we see 2 words over here, and therefore we say this is 2 gram. If I say I love you, there are total 3 grams over here. Each word is called as grams, and therefore we call it as a n-gram. Okay, so now let me get to this concept of n-grams. How does NLP actually tackle it? So this n-grams is available in the TextBlob package, and it returns a list of tuples of n successive words. For example, if I say I have TextBlob of, I say, sorry, I say, good morning, dear. I love you. Thank you for being my life partner. Okay, fair enough. So we see a lot of n-grams over here. Now I just have to give over here blob.ngrams function, and I have to specify the value of n. So if I give the value of n as 2, you can see it has automatically recognized all of the possible combinations. Now some unnecessary combinations do also come over here, but this is something which we usually take off when we are filtering the text. Okay, now in fact you can have this n-gram value to be set to 2 also, or 3 also. So if I set it to 3, you can see all these 3 words combinations, good morning dear, morning dear, all of these combinations are being extracted. Okay, the next one is the POS tagging, which I just showed you. Now we are moving on to a slightly higher level. So as I told you, following are the parts of speech tagging: determiner, preposition, JJ for adjective, then NN for noun, NNS for plural noun, NNP for proper noun, so on and so forth. Okay, you need not remember all of this. These are anyways available in the documentation part of it. But now coming on to pros and cons of it. If I talk of the pros, so since you see over here TextBlob, it is built on the shoulders of the NLTK library. Therefore, it is making it very simpler for the beginners by providing a quite intuitive interface to NLTK. Right? If you look at NLTK also quite functions the same. It also provides language translation and detection, which is powered by the Google Translate, which is not provided in the advanced package of natural language processing, which I told you during the presentation is called as the Spacey. Okay, so these are the advantages of this TextBlob. Now coming on to the cons of this TextBlob. First con over here, it is kind of slower in comparison to Spacey. So Spacey is much more faster. Okay, it is much faster than NLTK also. Okay, so the fastest is Spacey. Then after we have TextBlob, and thereafter we have NLTK. So we are studying this at the moment, right? This is quite advanced library, but we cannot take it in the webinar in a single 2-hour session. Now next con over here is it does not have features like dependency parsing or creating word vectors, which is provided by Spacey. So if you have functions like count vectorizer or creating a word of vectors, all of these higher level functions are provided by the this Spacey. It is not provided by NLTK or TextBlob. Now moving on to text classification. Okay, now this is something, let me be very honest to all of you guys, this is something which is not working as expected because it is having a very small amount of data, but this is just for understanding purpose before we move on to the project. Okay, so now we see over here, we have the train data over here. What do we have over here is the sentence and its sentiment, whether it is positive or negative. So this is an excellent movie, is positive sentiment. This movie was fantastic, I like it, is positive. Similarly, we have it was very boring, negative sentiment, so on and so forth. So we have this train data, we have taken it in a list. We have this test data, we have also taken it in a list. Fair enough. Now what are we going to do over here is we are going to use TextBlob, and we all know that TextBlob provides basic text classification capabilities. Now definitely I will never recommend that you use TextBlob for text classification because of its limited capabilities. However, if you really have limited data and you want to quickly develop a very basic text classification model, then you can use TextBlob. But for advanced models, I definitely always recommend using the machine learning libraries like scikit-learn or TensorFlow for it. So let me simply have this thing executed. So I have this train data and test data ready with me. As you see, the data set consists of the dummy reviews about the movies. And we also have our training and test data set consisting of tuples, right? Now let us train it using the neo-bias classifier from the TextBlob.classifiers library. So for that, I simply say over here from TextBlob.classifiers, please import for me neo-bias classifier. Okay. Now, once you are done with this, to train the model, we have to simply pass this training data to the constructor of the neo-bias classifier, and the class will automatically return the object trained on the dataset and properly do the predictions for us. So I simply have a object created over here by the name classifier, and I call my neo-bias classifier, and I say that whatever is the trained data, go and study that data. So this classifier will study this data and try to understand the relationship between this first value and second value. Okay. Then again, this first sentence, this sentence over here, the move and this sentiment, so on and so forth up to all these values. So this would be done over here. Now, once it is done, I will simply ask the classifier to do the predictions for me. So I simply say over here, classifier, can you please classify for me? Okay, classifier dot classify, and I'll give a sentence over here. So I say it is very boring, and let me see. And you can see over here, it has properly said that it is a negative sentiment. That is because it has been working on this data, and you can see it is not exactly the same sentence which I gave. The sentence is it is very boring, whereas in the train it was having it was very boring. Okay, now let me give you a positive sentiment over here. So let me look at some positive. This is an excellent movie. Okay, so I'll just try. As I told you, it is not working as expected because we have very less data. So it is, let's see, as I told you, it is not working as expected. Okay, so it is again giving me a wrong value. It is excellent as a negative sentiment, right? So it looks like a negative review. Ideally, it is not. Now, you can also make prediction by passing our classifier to the parameter of the TextBlob object. For example, you can also write something like this. I can say, let me have TextBlob directly over here and a sentence over here like it is a fantastic series, full stop. And now I directly give the classifier here itself, and I say classifier is equal to the model that we created above, which we labeled it as classifier. So that is what I have given over here. And I directly ask him to print for me the sentence, whatever it is written above, and classify it according to the function. So you can see it is saying it is a negative sentiment, right? Quite surprising. Let us see the accuracy of this model. So I say classifier dot accuracy. Now this may give some kind of insights, right? So let me see it on the test data itself directly. We had the test data created above. Now here is the catch. You can see the accuracy of the model is very poor. It is hardly 66% accurate. For a model to be actually deployed in a real-time project, it has to be minimum 85 to 90% accurate. And that is the reason we are getting wrong predictions over here, right? So now let us start with the main thing of the project over here. So in this section now, we are going to start the sentiment analysis project. It may take a while. So now, what we are going to have over here is we'll be analyzing the sentiment of the public reviews for different food products which are purchased via Amazon. And we'll use the TextBlob sentiment analyzer to do this task. Now this data set can be downloaded from Kaggle, or I can also give you the data set. So let me initially import the data set for you. So I simply say import pandas as PD. Then I say I'm going to import numpy as NP, and let me have let me give a very simple name. Data frame is equal to PD dot read underscore CSV, because it is a CSV file. I'm going to read that. So I just use my name of the file is reviews. I'll show it to you in a second. So reviews.csv. Rather, instead of reading the whole file, because it is a very big file, I'll just read the head of that. So let me initially read the whole file for you. So I say pd dot read underscore csv of this. The file is being read. Now instead of that, as I told you, these are something which is not we need not worry about all these things. Now let me not read the entire data set, because as I told you, it is quite big. So I say over here, in this data set, I'm going to use only the first 20,000 records of it, else the training is going to take a really huge amount of time. So I simply say in this data set, I want to use the first 20,000. So I therefore say df is equal to df dot head. Okay. And once that is done, you can now check shape of this. As you can see, it's taking time. Till then, let me show you the data set over here, which is reviews data set. You can see the size of the data set, right? It is quite huge. Right? I can show you in the properties also. The size of the data set is 286 MB. So you can imagine what kind of data set it is. So therefore, it is taking a lot of time to read. Okay, so now we have actually done our task successful. Now there can be some records over here. I'm not going to go into the cleaning task of it, but I'll simply drop out the NA values over here. So I simply say df dot drop NA. Let me see if there are any NAs over here. So I use the df dot drop NA function, and now let me check the shape after that. So that will actually make. Okay, so that means the data set is quite clean. We need not worry about the pre-processing stuff. Let me look at the head of this data set now. Okay, so that's how the data set looks like. So just observe what is the data set consisting of. So from the output, you can see that the text review about the food. You have to scroll this to the side, and you can see this text column, right? So you can see the text review about the food is contained in the text column, and the score column over here contains the ratings. This is something which we are going to focus. The score column contains the ratings of the user for the particular product, with 1 being the lowest rating and 5 being the highest rating. Okay, so let us look at the distribution of the scores. So I simply say for that I have to import Seaborn as SNS. Then let me import matplotlib dot pyplot as plt. Then I say percent matplotlib inline, so that all my graphs get plotted in the notebook itself. And now I simply say sns dot distribution plot of what. I say inside df I am interested in the distribution plot of the score column. As you can see over here, this thing is available, and you can see that most of the ratings are highly positive, that is 5. Therefore we see this 5 as the highest, right? Let's plot the bar plot now for ratings to have a better look at the number of records for each of the rating. So I say SNS dot count plot over here. I say on x-axis I want it to be equal to score, and I want the data to be equal to, of course, as I told you, you should understand what is the how to work with all this that we already study in machine learning. Okay, so this gives a quite good idea that 12,000 records are almost 5, and lower rating values are quite lesser in number. It gives a good insight over here that more than half of the reviews are 5-star ratings. Now let's randomly select any one of the review over here. So let me say I am simply taking the review of this text column, and let me have the 350th review. Okay, so this is the review that is there. These chocolate covered espresso beans are wonderful. The chocolate is very dark and rich, and the bean is very delightful, blah 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 blah. So it looks like the review is very positive. Okay, now to find the sentiment of this, we are going to use the sentiment attribute of the TextBlob object. We have already studied that before, right? So we know that it is going to return the polarity and the subjectivity, where the polarity will be between -1 to 1, where the reviews with negative polarities have negative sentiments, while the one with positive will have positive sentiments. And the subjectivity, basically, it is going to quantify the number of personal opinions and the factual information contained in the text. If you say something is highly subjective, it means that the text contains personal opinion rather than a factual information, which we don't want. Okay, so now let us use that. So I simply say let it be called as a TextBlob object. So I say TextBlob, and the name of the data frame is df. Inside this I am interested in the text column. Sorry, it's text. So it's the text column, and I'm interested in the 350th review, right? So okay, I say, can you print for me TBO dot sentiment? And we can see over here the subjectivity is this and objectivity or the polarity is this. So the output shows that the review is positive with a high subjectivity, almost 66% subjective, right? And it sounds also as subjective, you can see over here. So now let us add a polarity column, sentiment polarity column in our data set. So our data set consists of 10 columns. Let us add one more. So what we can do is let us have a function over here. Let me call it as find polarity function. This is going to take review over here, and it is going to return text blob of review. Fair enough. Dot sentiment dot, I'm only interested in the polarity stuff. Okay, the function is ready. Now let us have this df, and I'm going to give text column, and I'm going to say please apply for me the function which we just created above, which is called as find underscore Paul. And whatever is the result that this function is going to return, we are going to store it in a new column. So let me have this new column created. That would be in the data frame. I want a new column to be created. Let me call it as sentiment underscore polarity. And once you are done with that, I just want to check the head of this. I hope everyone is following. Please reply in the chat section. Are you following the things? As you can see, the things are getting a bit more complicated now, but are you able to follow the things? That's more important. Yes. You can see it's taking a lot of time because it is going to work on 20,000 columns, right? Okay. So let us see whether a new column is being added by the name sentiment. Oh, I'll go to the rightmost. Yes, and I do see sentiment polarity added over here. Okay, so now once this sentiment polarity is added, now let us see the distribution of this polarity. This is again very important. We cannot directly start working with the ML dataset. So I say SNS dot best plot, and inside this in the DF, I am interested in sentiment polarity. Okay. Okay. So this is how the distribution of the data set is. What do we understand? We understand from this figure that most of the reviews are positive, right? And they have the polarity between 0 to 0.5. You can see over here, most of these have polarity between 0 to 0.5. And this is natural since most of the reviews in our data frame has 5-star rating. So obviously the reviews are going to be positive, but we just confirm it over here. Now let us also check the average polarity for each score rating. So for that, I simply say SNS dot bar plot, and I say my X is going to be equal to the score column. My Y will be equal to the, I don't know why doesn't that come, sentiment underscore polarity column, and the data over here is going to be is equal to the data frame. Okay, so again you see a plot over here, and the output clearly shows that the reviews with high ratings have high positive polarities. Okay, now let me show you some negative reviews also. Okay, the reviews with the polarity value of -1. So what we can do is in this data frame, I say I want to find out df dot in the sentiment polarity column, if the value is equal to -1, show me that all things. So please convert that initially to the text format, and then only you can show me the head, else it's going to commit an error over here. So we can see over here, following are the things. You can see these are the ones which are having total negative polarity. These chips are nasty, all my fault. You can see the sentence is having a very negative slang. Okay, ops are basically horribly overpriced, so on and so forth. Now what we can do is, now let us print the value of this review 545, the very first one. So what I simply say over here is we can say in this data frame, in the next column, I'm interested in 545th review. Okay, so I got this entire thing. So you can read out. These chips are nasty. I thought someone had spilled a drink in the bag. No, chips were just soaked with grease. Nasty, nasty, nasty. So it clearly shows that it is highly negative, and therefore the polarity was equal to -1. Okay. Now, similarly, let's find out the one with the most positive polarity. So I have this. I say I want the polarity to be +1, and we have this, and this is 106th. So let us see 106th review in detail now. So I have this, sorry, 106. Now what I'm expecting in terms of company's reputation for excellent home delivery products. So you can see it has a lot of positive review over here. So you can see that the review over here, we cannot say it's 100% positive, but it has been assigned a polarity of 1 due to the presence of the words like excellent, home delivery, reputation. And it is important to know that the sentiment analyzer is not always going to be 100% error proof. It can also have, or it might also predict wrong sentiments in a few cases, just as the one which we saw in the previous example. Now, for example, let us look at the third one also. We're almost at the end, just last 2 minutes. So 223. So we have 223 over here, And you can see this is an excellent tea, one of the best I have ever had. Quite good, right? It is especially great when you prepare with a samovar. Okay, so what do we conclude over here? That Python's TextBlob library is quite famous, quite old, and quite widely used natural language processing libraries. Without this, you cannot go ahead to understand what is SPACY and NLTK. In fact, NLTK can be done, but SPACY, of course, requires a prerequisite of this. Okay. So what do we see over here? We saw some important fundas like what is tokenization, what is stemming, lemmatization, what is word inflection, sentiment analysis, text classification, and to some extent language translation also. So with this, I'll just have a cell over here.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.